So I'll start in a minute.
Sure, sure. No hurry.
Okay, so I guess it's time to start. Hello, everyone, and welcome again to yet another episode of Science and Society. Uh, so the idea behind organizing this series came about sometime last month when Mahavir Narwal passed away of COVID on the 8th of May. He was a scientist based in Rohtak in Haryana who was committed to social justice and embodied the image of a scientist whose vision stretched beyond the lab into a concern for society, for politics, and for a hopeful future for humankind. So it's to him that this series is dedicated. This series brings together a group of eminent scholars who share a progressive vision of the relation of science to society. It's a vision which sees, as Periyar and others did, a role for a scientific and rationalist temper in challenging socially oppressive hierarchies. It is a vision that sees the importance of an ethical role of science and the ethical engagement of the scientific community. And finally, it envisions science for the many and not just for the few. This series of talks and discussions is intended to be a set of informal evening talks around these themes. And they will take place on the same Zoom link that you have used to join this meeting every Monday at the same time, 6:30 p.m. IST. For today's talk, we are very pleased to have with us Professor Sunil Mukhi, who's a professor of physics at IISER Pune. Sunil completed his PhD from Stony Brook, and that was followed by a postdoctoral stint at ICTP in Italy. Then he was at TIFR Mumbai for a long time until 2012, when he moved to IISER Pune, which had just recently been founded, as the head of the physics program. His areas of research are string theory and quantum field theory. And he also has a very keen interest in various other things like Indian classical music, science popularization, cooking, among many others. And today, he's here with us to talk about the relevance of basic science in society. So thank you, Sunil, for accepting our invitation to come and speak over here. And it's over to you now.
Thank you, Sushant. And thank you all for coming. It's really an honor. And I must say honestly that I missed the fact that this series is in honor of Mahavir Narwal, but now that I know it, I'm all the more honored to be speaking in this series. And actually, honestly, I would have, I could have given perhaps a different talk, maybe more in keeping with some of the sentiments you mentioned, particularly social justice, which is something that concerns me a lot and a lot of the time. But here I'll do something different. I'll try to talk from my perspective as a scientist, looking at the very basic properties of natural laws, and try to highlight a picture which is not the one that we are reading about these days in media. Honestly, neither from conservative nor from liberals all that much. And it just innovates. My only excuse is I'll be recounting a few facts from history. Those are just, I think those are facts. And what is the relevance to us for the future, what lessons we should learn from the future. I won't insist or won't try to draw any lessons. I'll leave it to the audience and to anyone else who'd like to think about it. So to get started, uh, yeah. Um, I think everybody would agree that in the last couple of decades, the way we live has undergone a major transformation. When I say we, I guess I really mean to a large extent people who are either in countries like India who are largely urban, maybe not so much rural, maybe some rural people too, not all by any means, and of course the developed world. And it's not being very well appreciated how much of a role and what sort of role basic science has played in this transformation. And I don't feel that there's as much discussion as there should be. And so I'm just going to discuss that. And for that, I'll review some examples of what actually happened in the last century and how it affected our lives today. And then I'll ask some questions which, frankly, may be a little bit uncomfortable about the way we formulate policy these days. And again, I'll just leave them out there. Okay. Now, this institute, founded in the early part of the 20th century, was founded by Abraham Flexner, who had this wonderful quote, which does go around a lot. Throughout the whole history of science, most of the really great discoveries, which had ultimately proved to be beneficial to mankind, had been made by men and women who were driven not by the desire to be useful, but merely the desire to satisfy their curiosity. This will be a recurring theme in my talk, and I'm suspecting that many people think this is a appropriate theme for the 1930s or 40s, but not an appropriate way to think in 2020. So that's one possible way of looking at it. But I think slightly differently. I think this fact is something that for which we need from which we need to take a more powerful lesson. Now, there's a curious quote I came across in this book called Introduction to Physics in Modern Medicine, where you wouldn't expect to find this statement. No easy dividing line exists between curiosity driven research and applied research aimed at a useful biomedical outcome. And I would say that, considering at this moment the entire world is engaged in applied research aimed at a useful biomedical outcome, which is namely saying that people don't get COVID, or if they get it, then they don't die from it. It's very strange to see that the dividing line between curiosity driven and targeted research is not quite so solid as we think. So let's see. Now, let's try to classify types of social benefits. When we say social benefits, of course, there are the obvious physical well-being, which is medicine, housing, nutrition, security. And there's mental or social well-being, so socialization, enjoyment, learning, entertainment, all fall, communication fall under these. Now, basic science has transformed both in really unimaginable and very unexpected ways. And I'll try to again highlight why, I mean, how it was that something had an impact on society, though its inventors had absolutely no expectation and no intention, frankly, of transforming society. And I think one of the key reasons is that basic science, as its intrinsic nature, it identifies multiple linkages between different ideas and brings on board people who can link different ideas. Uh, and this is not quite interdisciplinarity as understood today, where we take people who have different specializations and get them to collaborate. In basic science, it often was the case also that people who had one expertise added another one, or more, or somebody after them took that idea, understood it, and transported it into a different domain. And this has led to game-changing applications. So without any further ado, let's make a list of advances. Then let me make a few, pick a few cases, and let's go into a few case studies, not in great depth, but at least superficially. I'll cover 4 different topics. So here are a set of advances that people would agree define our age: computers, mobile phones, telecommunications, cryptography, novel materials, GPS positioning, which I put in because it's not part of any of the others. It seems minor, but it's actually rather important today. These on the left are all things that came out of physics or mathematics or and engineering. On the right, I'm putting things which are more medical related: medical imaging, laser surgery, ultrasound, keyhole surgery, Doppler cardiography, and radiation therapy. And One thing that we should pause to think is that if this slide was up 20 years ago, one might have been tempted, or 30 years ago, one might have been tempted to say, well, all of these are really going to only help a very, affluent section of society. Is not really true anymore when it comes to things like mobile phones and computers and telecommunications. Not true even with novel materials. Not true even about cryptography, and it's not true about most of these things on the right side. So, time certainly changes how widespread the applicability is. Now, just because I see a lot of young faces in the audience, which I was anticipating, we should remember that our ancestors in 1850 might have a hole in the head, like this poor skull that you see here, but they had no way to figure out where or how it was located or what could be done with it because no X-ray. There was no treatment for Parkinson's, a very widespread disease now, till the 1960s. This is what a computer looked like in 1965. It could fill a whole room. This is what a phone looked like in 1970, and actually for quite some time after that, I would say right through even the 80s. And there's a lot people like me have a lot of fun asking a young person to actually make a phone call using this thing, and it usually confuses them no end. And this is how we listen to music. And one thing that, because I like music very much, I want to emphasize that until the 1980s, until the 2000s, a poor person had only the best option of buying a medium wave radio and hoping that in between government broadcasts of news they could hear a little bit of popular music, which usually in one direction only, completely monochromatic, like Hindi film music or whatever. And it was unthinkable to me as a fan of music that in 2020, for free, having an internet connection, of course, I can the kind the I can have access to more music than I could hear in the rest of my life. So, well, these things everybody agrees. Now, a lot of the credit goes to engineers, businesses, governments, the enlightened ones that took scientific ideas and did something to convert them into viable applications. And a very outstanding physicist called Michael Berry has written nicely about this, and tried to explain, how one should consider this part also very important. But fact remains that without the basic science ideas, there would have been no applications, without the basic science ideas and actual results. So let's look in a little detail at examples where basic science sponsored a revolution. And the examples I'll be giving are from physics and maths only because I know a little about these subjects, but there are examples in many other fields of science. And these are the four that I've picked to talk about: X-rays, lasers, general relativity, and prime numbers. And X-rays, I'll briefly discuss their role in medical imaging. We all know it, but a little of the background from those times might make it a little more real for us. Lasers have many applications, industrial applications, but I'll just focus on the medical ones. General relativity has had an unexpected application to global positioning, which is the maps that we use to find our way around. And prime numbers has an important role to play in security, banking, including the fact that we can make internet transactions in a secure way at all. So let's talk about X-rays. Well, everyone knows this part of the story. Wilhelm von Röntgen was doing studies on electrical discharge in vacuum tubes in 1895. His goal was to investigate the fundamental properties of matter, and electricity was the fascinating subject then. And you could study electricity best in a vacuum tube, because then if you got something, for example, the photoelectric effect was studied in vacuum tubes, because if you could get something to emit charged particles, namely electrons, then in a vacuum they would propagate to the other end, so between anode and cathode, and you could deflect them and you could try to do various things to them, and the atmosphere, the disturbance due to the atmosphere would not be there. So he had this lab and he was tinkering around, and he accidentally discovered a new kind of radiation that today we call X-rays. And of course, a very popular story is that the first X-ray photograph he took was that of his wife's hand. And this was the first time anyone had seen a human skeleton other than a real skeleton of a dead person. I mean, a living skeleton had literally never been seen before, complete with the wedding ring on the ring finger. And so when Anna Ludwig saw it, she exclaimed, "I have seen my death," which is absolutely appropriate given that, yes, people saw skeletons in their medical classrooms, but never associated with themselves. By the way, these images required up to 90 minutes exposure. There was a fair amount of damage to people because it wasn't known how dangerous it was. Later on, radioactivity had a very bad effect on Marie Curie, who died of radiation sickness. So yes, there was that because it wasn't understood. But this was a revolution in our understanding of radiation. Now, what did it do for society? Well, a lot of wars were going on in this period, and soldiers were receiving gunshot wounds. One of the wars was in South Africa, the Boer War, and but it was a period of a lot of wars. And the problem was that if a soldier had been shot, they would have a wound, but it was not clear whether they had a bullet inside them as a result of that wound. And surgery textbooks, and here I found actually online a very nice illustration of a surgery textbook, so a scan of a surgery textbook of the time called The Mechanics of Surgery, which had, as it says, detailed descriptions and illustrations and lists of the instruments, appliances and furniture in modern surgical art. I think this is late 19th century or early 20th. And so what did these so what were people doing? Well, their challenge was to find bullets inside soldiers' bodies, and engineers and medical researchers kept working to improve the probes. And I'd like to show you a picture of these probes because it's unpleasant but fascinating. Here are three types of bullet probes called Nelaton's bullet probe, elastic bullet probe with porcelain head, and Sen's bullet probe. And all of these worked by the surgeon holding one end. I think it's the right end in these figures as far as I can make out, and then poking the other end into a wound and moving the tip around and then the question was the following. So the tip would either encounter a bone or a bullet. So the idea was to distinguish a bone from a bullet. How do you know if I'm poking a tip into someone's body, whether it's rubbing against bone or bullet? And the difference is the bullet being made of metal would be smoother, and the bone being made of bone would be more rough. And it was by this procedure that you could figure out which of the two you were looking at, and then you might consider going into surgery if you really thought it was a bullet and getting it out. If it was a bone, you might just patch up the wound and hope that it will heal. Now, obviously, these books were being written by people in the medical profession, and no one was seriously thinking that you could do better not torturing the poor injured soldier by poking things into the wounds, which are already probably very painful, but by seeing through the body. And nobody seriously imagined this. And it has been said, and this is not me gloating because I'm a basic scientist, but it has been said in the history of the time that this fundamental research on X-rays contributed more than all the combined efforts of the engineering and medical communities to improve bullet probes. And this is not a poor reflection on anybody. If the dominant the dominant idea was that, well, we have to find the bullet, locate it, the only meaning of location was to find something physically. There was no meaning to shining a kind of weird kind of light and locating something because that light happened to be of a penetrating kind and would see through the body. And here's my favorite picture. So I actually had to take someone to KEM hospital in Pune for an X-ray, and found that Mr. von Röntgen's picture is garlanded in KEM hospital. And well, when I saw this, I said, I love Pune, and I still honestly love Pune just because I saw this, and I'm glad I took the picture. I mean, I'm not a great fan of garlands, but if you have to garland anyone, I would say this is a very, very good choice. Okay. Good. Let's move on to lasers. Now, here's an interesting story. It's a little more modern. It wasn't done by like one person. Well, it was done by 3 or 4 people. But the steps were interesting because they were very, very spaced out. So the first step was Einstein, of course, was the first step for a lot of things. And basically, using the newly discovered quantum theory, he gave a kind of proposal for optical pumping, which could take a system of atoms, get them into an excited state altogether. And he worked out some basic formulae for something that are called A and B coefficients. It's still taught in classes on quantum theory. And that's 1917. Of course, in between there was a war, major war, but it took really 41 years before Shorlow and Towns in the US and also Basov and Prokhorov in the Soviet Union published a theoretical proposal to make this a reality. And then once that was done, it took 2 years for Theodore Myman to actually manufacture the first working prototype of a laser. Now, the interesting thing is, I'd like to show you the excerpts from the papers. So this is the abstract of Shorlow and Towns' paper. It says a lot of things to us. It's from 1958. It's published from Bell Telephone Laboratories. And the interesting thing is, if you read the entire abstract, there's absolutely no reference to any possible use that this idea of extending what are called maser techniques to infrared and optical region might have. And if you read the entire paper, which is only a few pages, in those days all papers were only a few pages, you also won't find any mention whatsoever of any application. So they just took it as self-evident that extending maser techniques, whatever those are, it's actually the same thing, but in microwave. So M was microwave and L is light. So extending from that part of the spectrum to the visible part of the spectrum could have important applications, they assumed, but they didn't say anything about those. They just said it's a problem and this is how we propose to do it. Now, even more interesting is the paper of Myman, because this is the entire paper. This is the whole paper from beginning to end. So when I said papers were short in those days, I really did mean it. The whole paper has 3 paragraphs. The right one is in smaller font because I just shrunk it, but it has 3 paragraphs, and then 1 paragraph of acknowledgements and 4 references, and that's it, and a couple of figures. And if you see his affiliation, that's also interesting. The Hughes Research Laboratories division of Hughes Aircraft Company, Malibu, California. So Shorlow and Towns and also Myman, when they should have been making telephones and aircraft, were busy doing something that they couldn't propose a use for. And if you look at Myman's paper, it's all on the screen now. I challenge you to find anything about what use this might be. Again, all he says is this is a prototype to realize what those guys did. So Shorlow and Towns is reference 1. He obviously didn't know about the Soviet work, which was done independently because that was a Cold War period. And well, he just did it. So as I said, none of the papers discussed any possible application, didn't even suggest there might be a possible application. Despite this, industry seemed to have funded and at least tolerated these people to do their work there. Now, that's not completely true because I read recently that Towns moved from Bell to a university position precisely because he thought Bell telephones would not keep tolerating him indefinitely while he was doing this crazy work. And he felt a university environment was better. So he did. But even so, at least Bell telephones and Hughes aircraft, of which both of which we have certainly heard about in other contexts, was clearly implicated in the invention of lasers. Now, in fact, one could argue that the United States rose to be the leading world power in the 20th century to a very large extent because of this joint government and private sponsorship of basic science. I'm not a historian, I could be wrong, but largely or to some extent, I cannot say which, but certainly we know that the US is, where things like automobiles and washing machines and TV and all that were invented. But I believe that that all happened in a background where the belief in basic science was just very powerful. It just very powerfully grabbed people at the time. Now let's take a quick look at where lasers have reached today just in medicine. This is only medical applications of lasers, and it pretty much uses all kinds of frequencies across the visible and invisible, neighboring invisible parts of the spectrum from IR to UV. And everything, apparently every laser can do something for the human body. Some of these applications may look more exciting than others, but glaucoma, or also nowadays, lens cataract treatment and so on. General surgery, so the infrared lasers are typically involved in that. The dye lasers. So there's so many different types of lasers. That's my point. If you open Wikipedia, this is a small part of the full list of applications of lasers, and certainly not Shallow or Towns or Myman could have had any clue that this was going to happen. Okay, let's move on. I'll be more brief now, also partly because of time and partly because I don't want to belabor the point too far. Albert Einstein proposed his theory of general relativity, or general theory of relativity, in 1915. 10 years after, he proposed special relativity and a whole bunch of other wonderful things. And this theory is very abstract. This is, I think, the most difficult branch of physics, just in terms of difficulty. I mean, it's very difficult to learn, it's very difficult to understand, and it rephrases the law of gravitation in a new mathematical formulation as the curvature of space and time. And even among physicists, let me say, very few people understand it. I mean, it's a fact that I would say something like 90% of physicists working today probably have never had a course on it, maybe more than 90%. And those who have, I think 90% of those haven't thought about it beyond the course, because unless you're in working in relativity or in some branch of astronomy that uses it, or astrophysics, you probably wouldn't, or in particle physics, you probably wouldn't need it. Now, it was long thought of as a very sophisticated theoretical science with some limited astronomical tests. Precession of perihelion of Mercury is mentioned, and that's a kind of thing that that people consider to validate the subject. But today we know that without it, the global positioning or GPS system, which allows you to find your location on a phone using a satellite, wouldn't work correctly. And it turns out that general relativity provides corrections to the classical formulae, which are based on Newtonian ideas. And of course, the corrections are very, very small. But what happens is that there are corrections in the trajectory of these waves that go between us and the satellites, the radiation that passes back and forth. And this has to pass back and forth several times over a period so that your location can be correctly identified. And over a few days, the error would build up to 11 kilometers if general relativity corrections were not taken into account. So here's an example. When we build a bridge, we don't need to know relativity. Even for aeroplanes, we don't really need to know relativity. But for this application, which is again a very common kind of thing nowadays, without general relativity, GPS wouldn't have worked. Now, it's interesting to consider a counterfactual hypothesis where this didn't happen. Einstein didn't, he did his other things, but he didn't do general relativity. We still were thinking about gravity. And we would be finding sort of unknown, ununderstood errors in our calculations, which would completely make the GPS system fail. And that's it. No social application, no social benefit. I say this because this is something I didn't realize till it had already been working for several years, and it's not that widely known that Einstein is not just behind lasers, but also behind this technology. Finally, a little one from mathematics. So, that pure mathematicians have studied prime numbers for centuries. Of course, the master of this subject in the early 20th century was our own Ramanujan. But before him, Euler in the 18th century um, did fundamental work on prime numbers. And that work has been refined a lot since then. We know a lot more now. And of course, in his time, there were no websites, no credit cards, and no internet banking. In fact, that none of this has really been around for more than a few decades. And had they existed, he probably would, he may or may not have cared. But public key encryption, which is a technology, uses prime numbers to actually keep your passwords and your data safe. Now, of course, people will immediately say, no, no, but they're not so safe. We know many examples where people crack these things. Well, the point is that in today's world, to crack these things, the person using the credit card or the banking has to make some mistake. While if public key encryption algorithms were not known, then the method would just be crackable from the start. You couldn't do anything to stop it. And I don't know how much people know or want to know about this public key encryption, but basically it is built on the question of how long it takes to factorize a very long number, maybe a number with 40, 50, or 100 digits, into its two prime factors. And how long would it take a person? And now, of course, we want to know how long it would take a computer. And the fact is that prime numbers work in this remarkable way that even a computer today working at its top speed would take more than a human lifetime to crack a good password. And well, again, prime numbers is not, what politicians talk about a lot when they talk about great things that have happened. Actually, let me go off topic a little and say I hear a lot about ancient India, but I've never heard any politician talk about Ramanujan, whose actual contribution about to the understanding of prime numbers is a very important part of this topic. So there's some selectivity there which I've never completely understood. Anyway, that was a digression. There are many more such examples. By the way, I'm happy to take comments and questions during the talk if anyone would like to ask anything here. And then again, also happy to take at the end, which is about 5 or 10 minutes away. So, okay, whichever. Just unmute and ask if you have a question. Okay, so here's a short list of many more such things. The understanding of microwaves led to mobile phones. Certain mathematical process called the radon transform led to magnetic resonance imaging, along with, of course, other understanding of magnets and so on. Radioactivity has led to surgical techniques, radiation therapies. Gamma knife is a kind of surgical scalpel, but made out of gamma rays. Raman spectroscopy has led to many medical treatments. Raman is the other person that I never hear anybody talking about. Raman and Ramanujan were both from the 20th century, both South Indians. Both did remarkable things in their fields. You can argue that Britain had a role in both of their work, but they were great people. But if we want to celebrate something which is really actively being used every day, Raman spectroscopy is used all the time in medical treatments. It's just amazing. Evolution, now on the biological side, about which I know less, evolution and genetics have led to effective diabetes treatment, for example, and I've heard some interesting talks about that. This people might or might not know. Particle accelerators at CERN in Geneva, as a byproduct, led to the invention of the World Wide Web. And the World Wide Web here is not the internet as such; it's more the concept of a web page. So when you type the address of a web page and go to a web page, that's the World Wide Web. And it's a way to store information that anyone can access when they want, at the time they want, which is a totally new thing. Earlier, information was communicated using internet or using computers by someone sending it to you. Here, the information doesn't reside with you. It resides somewhere and it's always available for you. That was a path-breaking idea that came up because people mailing information to others were just filling up the disks and storage capacity of the recipients. And people were like, I don't need 100 pages on rice cultivation. I don't do rice cultivation. Why are you mailing me 100 pages of documents? But if someone keeps 100 pages of documents on rice cultivation, anyone who does it, anyone who wants to do it in future can go there. And this became important at CERN because they had a lot of data and they didn't want to mail it to everybody all the time and just block everybody's device by filling it with data. They said, no, we are storing the data in this place. This is the name of the thing to access the data, and that's called a URL. And when you want the data, you go to the data. Data doesn't come to you. This is the real thing that CERN did to invent the World Wide Web. So, well, that's a bunch of stuff. So I'm almost done. These are most of my examples. Now, it's no secret that research planning has become more short-term, more goal-directed, and more narrowly defined in recent times. Now, it's not surprising. The world has failed to conquer poverty and deprivation, and has failed to provide a decent life for all, and this has to change. Politicians of the left and right and everywhere in between recognize that at least you have to admit this. It's a different matter whether you have to do something about it, but it's something that no longer is deniable. But it is thought that the correct change is to support primarily or exclusively application oriented research. And it's not that one shouldn't, of course, one should. But the extent to which this has become the dogma threatens to change the atmosphere that really gave to us some of the kind of innovations that I've just described. And I'd like to just say a few more words about that. So here are some articles picked off the net. And you see 2013, 2018, 2019 all have the same phrase in the title. And these are all vice chancellors or heads of agencies telling people in universities, look, this is what you need to do. And again, not opposed to it, but there's something being missed when this is the only thing we talk about. And this has kind of become a prevailing dogma, and I think it needs to be a little bit questioned and reopened. And one thing that maybe I should say right away, it's not only about money or resources. It's also about atmosphere. I'll make that comment at the end of the talk. Anyway, so to wrap up, I want to say a few things about just to summarize, and then I want to quote from a book which I came across not too long ago, and then I'll end. Now, these are the kind of seeds of what I call seeds of progress. I've talked about all of these, some of these, and all of these have led to the revolutionary progress and social benefit that I've just described. So the question you may ask is, well, all these things are done. Okay. I mean, one may, put a few bells and whistles on genetics and evolution, but really it's done. Or number theory, how can anyone do revolutionary work in 2021 of the kind that Ramanujan was doing in early 20th century? Quantum theory, relativity, all sort of done. There is a sense that basic science is done. It's a very dangerous viewpoint. It's happened before. It's always been wrong. Still, um, okay. One question I asked myself was, how were these breakthroughs funded? Who was the funding agency for these breakthroughs? I found some rather curious things which really are outdated. For example, this nice piece of crockery is what funded Mr. Charles Darwin. So his grandfather was a Wedgwood, and Wedgwood crockery today we know as makers of fine porcelain, but actually they didn't make porcelain in Darwin's grandfather's time. They made crockery which was mass appeal, attractive, like this cup you see here, but pretty cheap. So Mr. Wedgwood made a fortune out of crockery, and it's he who basically supported his grandson's voyage. So it was private money, to put it another way, not a funding agency. Einstein also, in a sense, did some of his great work before he was employed as a scientist. He was employed in a patent office. This is well known. But most research was supported by public universities, notably many in Germany, many across Europe. But we hear of Göttingen, and of course elsewhere in Europe we hear of Copenhagen. We hear of lots of cities named for the universities that were there, where quantum theory, for example, was developed. Later things after the war shifted to the United States, and that's why lasers, when we talk of lasers, we hear about the United States and the Soviet Union. But today, I think public funds are actually harder to get for curiosity-driven research than at any time in the past, even though the buzzwords you see in the funding agencies don't clearly say so. So the first thing is, I've certainly tried to market to industry that a little bit of their corporate social responsibility should go to seed possible breakthroughs. And after I've given talks very similar to the talk I just gave, The industrialist is like, nope, you tell me what I can gain from this, then I'll fund it, otherwise nothing doing. So that's that. No Hughes Aircraft Corporation or Bell Laboratories here. Particularly, this is a problem in India. I don't mind saying it bluntly. It's being recorded. You can, you can quote me. But the sad fact is that industry in India shows very little interest, except for a few isolated industrialists who actually care about these things. Governments are, particularly ours, is fairly positive about mega projects because mega projects propel us into some world leadership. I think that's how they see it, but less so about blue sky tabletop research of the kind that once gave us X-rays and lasers. And there's still a lot that can be done there, and it's not so easy to justify because there's an atmosphere in which uh, application has to be sort of highlighted before you get funding. Now, by analogy with the climate crisis and the need for renewable energy, I would like to point out a looming intellectual crisis, which is the following. You know, the sources of our technology are early 20th century. Are we providing the sources of 22nd century technology by doing basic science now? Yes or no? Maybe it's a very naive statement, but people who provided the basic science didn't necessarily benefit from it. Okay, the benefit could have come much later. Einstein was, practically dead by the time laser was a reality. He was actually dead by the time laser was a reality. So he didn't certainly benefit from it or get any even applause for that idea. But he, provided the resource, and it was used later. Are we providing resources which will be used later, or are we a parasite generation that's using up the resources, intellectual resources of science, and not providing anything new? The question. Okay, here's my guess on what might seed tomorrow's progress. This is not my guess, this is what everyone says. Magnetism, superconductivity, these are all new topological phases, particularly a new idea. Superconductivity, a field with a lot of promise, which has not been fulfilled yet. These could really revolutionize the world any day. Actually, one discovery in any of these could potentially revolutionize the world. Atomic and molecular physics, ultra cold atom physics, quantum information and quantum gravity. That connection seemed to be very exotic today and very theoretical. Elementary particle physics, particularly of particles that so far have not done anything for us, like providing surgery techniques or anything like that. They're just new. We don't really understand them that well, and we don't know what they could do. And of course, the great astrophysical unknowns, dark matter, dark energy, and a little bit gravitational waves, about which we know a little bit. So these are some of the seeds that people talk about. In addition, there are medical techniques that people are talking about. I put them down here. I'm no expert. These are mostly futuristic. Some are already being discussed. But these and the ones on the previous page are things that one can make a list of because they are very foreseeable. The problem, and as I said, superconductivity has not yet lived up to that promise, but it may happen. The problem, though, is that striking applications on the level of lasers, on the level of X-rays, probably won't be any of these, because these are things we can conceive, and those are things that people of that time couldn't conceive. They may come about by accident. And so essentially my last comment is that it's not just, this is not just a plea for basic science to be funded with lots of money, as to be supported by the intellectual climate of the times, something created both by people and by governments. It's not only, and by industry. Industry and governments have disproportionate power. And it bothers me that the intellectual climate today isn't acknowledging the things I've said and isn't trying to support our creation of resources, intellectual resources. Okay, now I'll conclude by quoting from this book called Scientific Freedom by Donald Brabin. And I was struck because he said things which I had thought and I'd never read about. Um, he says, most of the bounty of these technologies stems from generic scientific discoveries made decades ago, a source that seems to have dried up in recent years. Consequently, our intellectual account is becoming overdrawn at a time when the demands on it are increasing. There's no shortage of initiatives aimed to deal with global warming, population growth, terrorism. I should add COVID also. But one vital factor is usually overlooked. If current policies had been in place at the beginning of the 20th century, say, the world today would be a much harsher place. And today, the consequences are approaching the category of operation was a success, but the patient died and will affect the very foundations of our civilization. This is a very strong statement. I don't know if I would go that far, but it's not just me. I think this fear is there that we are not doing something we should do for the long term interest of civilization. So I'm reached the end now. I'll leave you with a quote that this person, David Gross, who I know reasonably well, and who came to India in 2016 for the Indian Science Congress, made a statement which I think was intended for our policymakers. He said, look, new inventions, technologies, products are in the end based on new discoveries and new understandings of nature, what we call basic science. So, he says, I would propose that you replace the slogan Make in India with the slogan Discover, Invent, and Make in India. So I think that summarizes the things I had to say, and I'll end here. Thank you. Happy to take comments, questions, complaints, or any other thing.
Thank you so much, Sunil. I'll invite anybody who has questions. Just feel free to unmute.
Prashant, your voice is coming through very faintly.
Is this better?
Much
Yeah,
better.
much better.
Okay. Yeah. So please go ahead and ask questions. Well, I guess I'll jump in and ask the first one then. What do you think has happened to prevent industry from really investing in basic science? Like even looking simply at Indian history, we have instances of the Tatas funding TIFR and IISc. And then what do you think has happened over the years or decades?
Yeah, I wish I knew. I mean, in my mind, Tata's is a good. I'm glad you brought up the example of Tata's because we all know what Tata's did even before TIFR, the Indian Institute of Science, Bangalore. So that was JN Tata and TIFR involved JRD Tata. But then, in the years I was in TIFR, we had fairly extensive dealings with the Tatas, although they don't fund TIFR much anymore. I mean, TIFR, as probably people know, is fully funded by the Department of Atomic Energy. And it was very difficult to get, after JRD Tata passed away, it was very difficult to get any support from the Tatas, even though actually they still have their name on the institute and their head still chairs the governing council of TIFR, for example. But the same company is not thinking the same way about the same things. Now, of course, every company will evolve and, probably they feel that, well, times have changed. There's some feeling that times have changed and we can't anymore afford to be bothered with this basic science stuff. I don't have a deeper answer than that. If someone can suggest what it is about times that have changed, which is requiring this, they're welcome to say. One guess I can make is that in the last few decades, a lot of society has emerged from previous generation poverty into middle class. And perhaps that emergent section of society feels that, I don't know if it's even true, but perhaps has a consciousness that, the applications of basic science didn't work fast enough for them, that they had their parents or their grandparents had a very difficult time, and that poverty is the thing we must focus on it. And nobody is saying not to focus on it, but the question is, must we focus on it? Should we hit the nail directly on the head, or should we try to find transformative technologies through basic science? That's the sort of kind of question. Yes, Prathamesh, please go ahead.
Yeah, so thanks for the very interesting talk, and I just had like a couple of questions. Yeah. So the first question was, of course, what about, I mean, of course, while we draw the distinction between, say, basic science and applied science, so, but what about the basic sciences in technology itself, right? I mean, for instance, I mean, within computer science, you will have like people working on theory of complexity and computability theory. which perhaps are much closer to what you'd call mathematics as than compared to say your artificial intelligence or machine learning or something to that effect, right? Or even within a mechanical engineering department, you'll have someone who'll be working on your fluid dynamics as opposed to say, right? I mean,
Very true.
numerical PDs, absolutely. So one of those questions was that. And the second question is, within the Indian context, can you think of some of the ways in which basic science has kind of contributed to the technological development? So that would be another question. So,
Yeah. So first of all, I think your point is correct. I think, when you ask about basic science contributing to technological development, it doesn't happen on that time scale. I mean, the case of X-rays is very rare and bizarre because no sooner had Mr. Röntgen got his X-rays than suddenly within a year, people were asking to use them on soldiers. It's that fast. That's just luck. Luck in the sense that what he found was applicable to the problem of his time. But with lasers, it took much longer time. With prime numbers, it took a much longer time. So, any basic science done in India now is not going to, first of all, basic science um, is not so national as, applied science has to be applied in the context of a country. Basic science, I think, has less of a context and you cannot directly link it that, I'm going to do basic science and it's going to benefit India more than it benefits Bangladesh or Sri Lanka. That's not how it works. So somehow the politician doesn't quite see it as a flagship thing of the nation. It's not linked with metaphors of nationalism and nationhood and all that. It's just not. Basic science doesn't do that. It was doing great in Germany till Hitler came along, ruined everything, and everybody moved off to the United States. A sort of rough version of history. So it can move countries. It could move. It could move to any other country. It may move to China. We don't know. So yeah. Now Naina has suggested that maybe it's linked to the global economic crisis. It could be. I don't know. Financial. Yeah. Are there conversations around utilizing the human resources available? Well, the undergrad population, section of science population is waiting for a chance to contribute. Well, I think it has a chance. At least I think the IISER system where I work was invented precisely for that, to give undergraduates a chance to contribute to science. So I myself in the last 6 years have done all my research with undergraduates. So yeah, I think they're there. Are there, so that's one comment. There's some hand raised.
I think Rishi has a question.
Please.
I think Vasudha had her hand up before mine. Vasudha, would you like to go ahead?
Thank you. Yeah, thanks, Rishi. Thank you, Professor Mukhi. It was absolutely fascinating to hear you speak. And I actually wanted to ask about something which you touched upon when you were when you were responding to Prathamesh, which is about that link between theory and discovery and those practical applications. If we could know more about how they have happened, the sorts of people who have worked on those, under what circumstances have they worked, questions of, what kinds of institutional or broader historical social circumstances have they worked? How has that actually happened? And, you've said that there is, there are these patterns of people. You said Einstein was an the case of X-rays were an exception, but in many cases, the application has emerged maybe several decades after the discovery. But are those similar patterns? So what sort of patterns would we see in the people who are working to actually establish this application? And that was something I was hoping you could talk more about.
Yeah, I wish I knew more about this, but what I can say is that if you take the case of lasers, why did this thing happen? Of course, this gap partly because of the war, but I think also because, to think of making a prototype of something, you need some technology buzz around you. So it's not that surprising to me that people working in Bell telephones who are working on electronics, and electronics was such an exciting subject in the 50s. It was new. And they were surrounded by electronics and communication. It's not that strange for them to turn their mind to something involving light and matter and electricity, like lasers. So sometimes the time is right when the technological background is right. But in that background, if everybody is pushing you to only work on the technology and actively discouraging you from working in the basic things, then obviously it will be a very rare person who goes against that grain. And Myman particularly, I think, was a very, very rare person. I haven't yet figured out why Hughes Aircraft Corporation tolerated him. But of course, eventually he was, he brought them lots of fame. But yeah, I don't understand the sociology in any proper detail. These are just, just observations that I have. There's definitely last comment I'll make on this. There's definitely something called, environment. And the environment isn't only what the funding agencies are giving you, but it may also be what your politicians are saying, what the industrialists are saying, what the thinkers are saying, what the social scientists are saying, and what other hard scientists are saying. It's the buzz. And uh, it could be that Twitter is not a place that you go and then you feel motivated to do basic science somehow. So although a lot of basic scientists propagate their stuff, they work on Twitter, but overall it's a little too noisy an environment. So I don't know whether we'll ever recover that sense of serenity with which von Röntgen could do his work or Einstein could do his work. There was certain serenity of their times. Maybe that's lost forever.
Rishi?
Thanks, and thank you for that wonderful talk, Professor Mukhi. I have a very superficial observation followed by a question. The observation was, so when you were speaking about the development of lasers, you spoke about the development in the United States, and in particular how that work was funded by, I think, Hughes Aircraft and possibly Bell Telephone Labs. But you also mentioned work going on in the Soviet Union at that time, and I suppose that was funded by government funding because I see industry coming in over there. And that suggests, as you mentioned in your talk, the importance of the larger intellectual climate, which you just spoke about right now a few minutes ago.
Yes.
So my question is, what should be done to sort of encourage the creation of that climate vis-a-vis the way science is taught in schools?
Yeah, that something I worry about constantly, especially because every year when I sit in PhD interviews, I feel more and more distressed about the way physics is taught in schools and still taught. I would have thought in 2021 something would have changed, but I am still faced with students who, if you push a button, like if you tell them a word like photoelectric effect or capacitor, they can immediately tell you from memory the one paragraph description around it. But if you ask them to just think a little bit, even think, how could this have been actually done? What do you think the person who did it was thinking when they did it? Can't address the question. I've even encountered applicants, I'm sorry to say this, in a public forum, who couldn't tell me what was the maximum current rating of the plug point behind them on the Zoom chat. They had a 5 amp plug behind them, and they're physics aspiring to do physics masters. They have done a master's in physics. They don't know that this 5 amp plug cannot give more than 5 amps without burning a fuse. So somewhere we're just not teaching people in school the thinking side of science. We are still teaching them the rote memory side of science. And I thought that was discredited decades ago, and there have been numerous education policies which talk of all the right words, but it isn't happening. But as you say, the Soviet Union had an amazing intellectual atmosphere. I mean, from anything Russia and so then Soviet Union, that stream of intellect from the great writers, all the Tolstoys and Dostoevskys, on to the great thinkers in every aspect, the great musicians, the great mathematicians, the great physicists. At some late stage in the Soviet Union, I sensed that mathematicians and physicists were not being encouraged by the government, and many were Jewish, and this wasn't going very well for them because there was a lot of anti-Semitism. But there's some period when I think the scientists felt supported. There was another period, the one I remember from 70s, when it was all about, the first day that they could pack up their things and leave the country. And then when the Soviet Union was disbanded, people promptly left. And I know personally many of them and just headed for greener pastures because it was no longer possible. So even Soviet Union went through that change where they became somewhat more hostile to the very basic science. And it was, that Landau Institute, the legendary institute in Moscow, in its last days, when the brilliant people were still there, people used to work from home, believe it or not, as we are all doing now, talk to each other on the phone and meet once a week in a cafe, and discuss physics for hours there. That was all. They didn't practically have any office staff or equipment or anything to support. They even had to type out their manuscripts on pathetic quality paper on a typewriter with handwritten equations. And till the 1980s, I used to read these papers coming out of the Soviet Union, and they just looked so bad as in terms of presentability, while Western world was coming out with nicely printed papers. So something changed in the Soviet Union, and I don't know what. China is the highest sponsor of scientific research. There's a comment here, which is absolutely correct. I have some comments about the Chinese model, but I'm not expert enough to make too many comments. Sham has a question. I don't hear you. I think your headphone mic isn't working, so maybe if you just unplug it, probably is better.
Yeah, can you hear me now?
Yeah, absolutely.
Yeah, so my name is Sham. I come from biomedical research, and I see this transition in biomedical research too. The NIH, which is a funding body in the United States, they seldom fund basic science research these days, and they go for applied or translational research. And I was wondering, like, when exactly in the history of science did this transition happen, and what was the primary reason for this transition? If you could provide your insights, that would be great.
My insights are that I have no idea when it happened and why it happened. All I know is that in India, I felt the atmosphere very positive towards basic science when I came back after my few years abroad to do my PhD. Just to give you one example, I actually imported a computer PC in 1984. And I got it through customs after spending a couple of days by waving a new law at them, which said one computer could be imported by a scientist. And you won't believe that when I was done with that exhausting day, the assistant collector and all the other customs officers came and patted me on the back and said, "Wonderful that a scientist has come back to India," and escorted me to the gate. I mean, I still remember, it was a different time. It was a feudal time. India was much poorer. All that I agree. And anyway, nobody's asking to be patted on the back by customs officers. But there was something. And it's not quite that thing anymore. So yeah, society has become a bit hard, or I don't know what you want to call it. Again, a lot of people should do translational research, but a few people should be given tranquility and security, including financial, but not only financial and job security, to think about things. And they should be trusted. I don't think scientists are trusted in India the way they used to be.
Sir, can I go ahead?
Please.
This is Harinandan here, sir. Thank you so much. And the number of people staying on the Zoom call, even after you have done your main session, I mean, before pre-Q&A session, it already tells a lots of quality of discussion that you have been doing here. So I have a question about how Israeli have been advancing in technology in a great way, be it defense technology or be it cyberspace or be it cybersecurity, in fact. So what are the some factors in their scientific temperament at the school level which the government is providing to their school students or to the college students? Any aspect?
Well, one thing, of course, is the fact that a lot of the scientists who migrated to the US and did great science, including mathematicians, were Jewish, and they had to run for their lives from Europe at the time. And some of them later moved to Israel, and there was always, at least among Jewish people, there is a sense that the culture, the intellectual culture and history and tradition that they sort of encounter when they grow up has a strong, scientific and a strong curiosity-driven aspect. I mean, that there is something cultural, but that's probably not enough. I suspect that in the case of Israel, it has always had very close connections with the United States. I mean, even now, going between Israel and the United States is just, it's been, I know a lot of Israeli scientists who are my very good friends. All of them have spent a lot of time in the US and a lot of time in Israel. And somehow this communication, cross communication is very strong, very powerful. So, a lone country which didn't have a much bigger superpower closely connected, I don't know how it would go. It's difficult to say.
Thank you.
But it's true that Israel is, it's true that what Israel is doing is amazing. That is certainly true. I know you, but you weren't called Lakshman when I last met you.
No, good to see you, Sunil. Quick question here, and thank you for a lovely talk as ever.
Thanks, John.
How much of course, how much of basic science would you attribute in some senses to the age of empire? And I say this even if the countries in question weren't purveyors of empire in the strictest sense. I'm talking about Germany and the United States. And once you have the fall of empire, in some senses, then you have the introduction of the scientific industrial complex in a massive way, and you're having major changes. And that is coupled with decolonization, dependency theory, and the fact that by the end of the century, right now at least, you've got the population quadrupling around the world. So given all of those considerations, what chance does basic science have against that background? Okay.
Good question, and this probably is the closest to an answer to what I was saying. Though I would ask you, when would you pinpoint the decline of empire in the United States?
No, I'm not. That's why I said strictly speaking, right? Because the argument has been made for soft empire, but the United States could always hide behind the coattails of the British Empire and the like. And when that goes, then the United States can come in and say, okay, now we're stuck with this. We become the police folk of the world. And that major change happens vis-a-vis another system, which is that of the Soviet.
But great basic science was done in the United States through the 50s, 60s, 70s, 80s, even 90s, even now. So, I mean, they have the military industrial complex. They have all the mania about doing translational and applied work. But basic science in certain enclaves in the US, I mean, I mentioned Institute for Advanced Study in Princeton for a reason. I've spent a year there, and nothing could be more tranquil and relaxing. And it's privately funded. And the funders are, literally elderly couples who have a little or a lot of extra money that they want to leave for a good cause, and they sort of contribute it and even come and visit the place and meet the scientists and have a little wine and cheese and talk a little and learn a little. But it's done by very rich people with a lot of humility. I was quite amazed by that because I saw some of these people, and that still happens. That never took off in India, as far as I know, or maybe very briefly. I don't know.
But that's part of the point. The United States could do it, especially. I mean, and with Star Wars, you can see this. It's a world system vis-a-vis, communism, capitalism. But with dependency theory, when you have ideas, when you say, okay, you're talking about in India, for example, temples of the future, you're talking about the Green Revolution, there's an immediate turn towards application almost immediately. There is a sense of running. And so when you have your Nobel laureate in Mysore essentially saying, discover, invent, and make it India, there is a certain hamstringing already given circumstances, right? So that's why I'm wondering what happens in the recently decolonized world, India being the one with which we are most.
I don't know. I just don't have a deep understanding of the sociology behind this. But I'm glad you made your comments. I mean, I think all the comments have been useful, and I'm thinking more about this than I probably have done before.
Thank you, Sunil.
Yeah. I would even go as far as to say I'm not as I'm not that disappointed in the Indian government as far as science is concerned. You can have all these, you have all the silly things that various people have said about science and all that. But all said and done, there is some functioning system of support to science, including basic science. I mean, LIGO, the Gravitational Wave Observatory, it's a new experiment is going to come up in India, and government is supporting it. But I'm more worried about about the social atmosphere, and particularly about industrialists, because I'm not seeing at all the same caliber. I mean, maybe there is, maybe these are people who support great universities, like new universities like yours and like Ashoka or whatever. But I'm not really seeing that when it comes to basic science. I've been very disappointed by that particularly. That's where for me India stands out. The idea of a wealthy, couple who have done whatever they want to do for their kids and now want the rest of their fortune to go not within the family but to nourishing the intellect. I've seen so many of these in the U. Everybody I know in the US is a David and Muriel something or other foundation fellow or chair professor or something. I mean, it's so much the couples, not only the businesses and industries. It's just families doing this. Yeah, Prathamesh, please.
Oh, hi. So there's just like a few more questions just came up in the talk. So one is that, of course, while we kind of think about often trying to pitch science through its through its technological advances, and sometimes it often works, let's say, if you're talking to an industrialist, or it kind of perhaps works to a politician or to a young student. But also, like, what exactly also about like science, a scientific temper in general in the social population, right? I mean, as an end to itself. And the second is, what do you see as potentially the role of, let's say, social movements, which kind of bringing out this enlightened aspect of science towards social transformation? Like, for instance, in Tamil Nadu, there was Periyar, but unfortunately, I don't think we had like people of such caliber across in India, right? I mean, so yeah, who kind of talked about science and scientific temper and rationalism as a point of social transformation itself. So yeah. So,
you're right. Scientific temper is one of the things we talk about a lot. And here also, I find something very interesting. In a place like the US, where I've spent a few years, what I find striking is not that you hear a lot of there are a lot of loony people, let's face it, and who don't take science seriously. But what's true in the United States, because I saw it firsthand, is that every homeowner has a garage with some tools, and on a weekend they are drilling or sawing or cutting or fixing or welding or doing something with their hands. There's a huge tradition of the middle class person doing technology with their hands. And that, again, I don't know how many Indian middle class families have a toolbox in the house and will pull out a spanner or a screwdriver when something goes wrong, as opposed to phoning up the nearest plumber or electrician. So there's somewhere it starts with that belief in actual technology helps you believe in science, in my view. Although the Trump era has challenged that paradigm a little bit. So because I'm sure that even Trump supporters do have the handyman thing at home, and they do the little home technology stuff, but they have this overwhelming disbelief in important basic facts of science and medicine. It's very strange. I don't understand it. Yeah, Indian hesitancy has to, Dakshi, thank you. Yes, Indian hesitancy has absolutely, in my opinion, absolutely to do with caste. I think the same thing which won't make us clean up something that spills on the floor is the thing which won't let us pull out a screwdriver and fix something, which is just somebody else has to do it, because those unpleasant things are done by a different type of person, not our type of person. I think caste is very, very key to this. It could also be really key to the idea of industrial families not want. Caste goes with ideas of heredity, ideas of family, importance of maintaining the family. So, it's hard to think that a family which has a lot of money will, in their, days of being very old and move, planning their move on from this life, will think of giving it all away. Perpetuation of the family is far more of a value, and anything giving away to third parties is a loss from that. Okay. So if there are no more questions, maybe then we can. Yeah.
Sorry, can I,
Yeah,
Sushant,
please.
if I may
Yeah,
go
please,
ahead?
please go ahead.
I'm sorry, sir, I cannot switch on my video. I just have one comment about why there has been hesitancy about scientific research. I'm not talking about basic science here, but I remember in after 9/11, there was a lot of challenge that all these activities were done by engineers who are looking for quick solutions, and therefore humanity should, be introduced big time. And that somewhere, I'm not, pardon my colleagues here, younger colleagues who are in liberal arts, it's not that, but there was a tendency then to revive humanities studies more, and STEM studies kind of took a little back seat. And we saw that in United States, for example, in presidential elections. You may recall there was a lot of talk about, especially Barack Obama and Bill Clinton, who were emphasizing STEM education because they realized that it is. So there was this, huge contradiction going on as to where the education policy should be. And that could have also had some impact somewhere as about the funding of the scientific research. That's one comment I wanted to know. I don't know if you or anybody else would agree with that, but that was a lot of the time in debate in following the 9/11 incidents. Second, I just wish to have, if you have a few minutes, you mentioned about that you have some comments about the Chinese model. I know it is very a precarious model, to say the least, and the methods of acquiring scientific knowledge are pretty questionable at times. But at the end of the day, just like in the economic area, they have become so successful, and nobody is questioning, how they got there. With forced labor and so forth. So is it not that now that whatever means they have acquired this knowledge, scientific knowledge, they have, stolen or not, or whatever people may claim it to be, that they are really becoming very, very dominant in this field. And we have seen, of course, with COVID as well, we have seen some very negative influence of that. What is your, just comment about their model and what impact it may have on scientific research in future? Thank you.
Yeah, so, I don't want to make a very sweeping comment about China. I don't
I
know.
agree.
I've only been there a couple of times. But my sense is when it comes specifically to building, we often try to copy the Chinese model in India, which is create a new institute, throw a lot of resources at it, and then, hope for it to reach some world ranking or something. And to give you a concrete example, I think recently Minister for Science and Technology proposed yet another new research university in India, which would achieve some world rankings. China has done, this is, I think, loosely copied from China, but there's a difference. China actually has created universities, has actually recruited people, even from outside China, at high salaries, causing upset to people within China who were in their other universities. But what China has done, which I think we don't do, and we will never do the way we are going, is that when they say they want a certain goal achieved, they're ready to put the resources behind it. They say, we'll give you this much if you can do research in this area. But it's not that after they tell you that and you join, the next year they say, oh, sorry, our ministry doesn't have any funds anymore. Instead of $100 million we promised you for this year, can you manage in $500,000? That's what they do not do. And unfortunately, the Indian way of copying this is to say, yes, let's set up a world-class university. Next year, it's like, yeah, we've set up the world-class university. Now, we'll give it a few lakhs to go on and expect it to manage and raise its own funds. All the promises that are made basically are forgotten. And now it becomes the fault of that thing that it never became world-class.
I agree. Yeah,
You
continuity is not there.
can make Delhi University world class if you want, but it's not going to be done by by fiat or by, you have to give it resources and you have to set goals, but you cannot default on your resources if you want to achieve your goals.
Yeah.
Everything I've seen in my years in IISER particularly were asking an institute to achieve its goals while completely defaulting on the resources.
Yeah, there I agree with you. Yes, indeed. Of course. Yes.
I respect the Chinese for the fact that when they want something achieved, they actually believe in it enough to stick with the resources, make a plan for many years, and then actually execute that plan. And there are results. There's a famous Nobel Prize on the subject of neutrinos, neutrino research, which China set up the thing, had a project, planned it, hired the right people, put the money, and got the papers and got the Nobel. They did everything from beginning to end. In our case, there's always an announcement of a buzzword which you don't hear later on, like institutes of eminence. When was the last time you heard about that? It was a buzz thing for a couple of years. Now several institutes are institutes of eminence, but now suddenly that thing, the excitement about that is lost. You have to maintain the excitement until it actually achieves eminence. And I think this really distinguishes Chinese from us. That's how I see it.
Yes, amongst other things. Yes, thank you.
Yeah, of course, they can be quite ruthless. That's also a fact. I think I'm an outspoken person. I might not last long in China, especially if I was being recorded. So all that is true.
Yeah, not only that, I worked there for quite a number of years, and I had longer periods of living there as well. One of the things I noticed was that they started with making very comprehensive universities, like, scattered institutes and everything, because they could do it, since the decision making is very centralized. Right. So universities became much bigger, to the extent that they were in the beginning not manageable, but then came, again, they used the term 9/11 projects, where they funded 9 universities very heavily to go into, the resources were really overflowing as long as they were able to, achieve the goals that were set for that. But it was a very systematic approach, which requires, a long-term commitment. That's there I agree with you that sometimes we do not have that. Yes, thank you. Thank you for your time.
Are there any other questions from the participants? Okay, if not, then we can close today's session. We'll all thank Sunil once again for a wonderful talk and question and answers and discussions following it. Just a brief reminder to all of you, we meet again next Monday, same time, 6:30 p.m. And our speaker will be Satyajit Rath from the National Institute of Immunology. And he'll be talking about COVID and scientific temper. Thank you very much once again, everyone, for attending. And we'll see you in a week's time. Good evening.
Okay, thanks all. Bye-bye.
Thank you so much, Professor Mukhi.
Thank you. You've been a wonderful.
Thanks a lot.
Thank you, sir. Thank you.
Thank you.
Thank you so much. That was a fascinating talk for us.
Thank you. I look forward to visiting sometime when it becomes possible.
Yeah.
Okay, bye then.